Okay, I'm going to go through some of the examples that we didn't get to in class in case you guys need some reinforcing. So first of all, we'll go back to example 3b. This one had asked us to write in slope-intercept form and standard form the equation of each line. So notice that we were given the slope and we're given a point. So the only form that we know enough information to plug into is our point slope form. Okay, so I'll start with that. Y minus y1 equals m times x minus x1. And I'll plug in my slope for m. My point is my x1, y1. So I'll have y minus 6 equals 5/6 times x minus 5. Now, they want us to rewrite that into slope-intercept form and standard form. Okay? So the first thing that we're going to do is we are going to distribute that 5/6. Now, when you multiply 5/6 times something that is not a fraction, you want to think of that number as being over 1. So we'll get y minus 6 equals 5/6x minus 5 times 5 is 25, and 6 times 1 is 6. Okay? Now to get it in slope-intercept form, the last thing I need to do here is I need to move the 6 over. So I'm going to add 6 to both sides. And I'm going to go ahead and make that 6 over 1 on my right-hand side. Now we know in order to add fractions we need a common denominator. So the common denominator between 6 and 1 would be 6. So I'll have y equals 5/6x minus 25/6 plus 36/6. Now be careful, you do have a negative whenever you combine these. This is a negative 25 plus 36, which should get me a positive 11. So I'll get y equals 5/6x, and since it's a positive 11, this will be plus 11/6. So that's my slope-intercept form. Lastly, I need to get it into standard form, which is ax plus by equals c. So the only thing you have to do is move this 5/6x over using inverse operations. So I will subtract 5/6x, and I'll get negative 5/6x plus y equals 11/6, which for my purposes, that's a fine answer. Now remember what I showed in class, that you can get rid of the fraction by multiplying by the common denominator. So if you were to multiply 6 by each of these, you would end up getting negative 5x plus 6y equals 11. That's another possible answer you could have. You also could multiply by a negative to have 5x minus 6 equals negative 11. All three of these are acceptable answers to the problem in standard form. Sometimes, if you see in the book, they oftentimes get rid of the fraction, so I wanted to show that to you in class. Okay, a couple other ones we didn't get to in class was example 4b with our given slope. So for this one, we are given 2 points. We are not given the slope, so that's always going to be the first step that we're going to perform. So we'll label this x1, y1, x2, y2, and then we're going to substitute into the formula, y2 minus y1 over x2 minus x1. So for my slope, I'm going to have y2, negative 3, minus y1, which is 1, all over x2, negative 4, minus x1, which is 5. So negative 3 minus 1 is negative 4, and negative 4 minus 5 is negative 9. Now notice we have a negative in the numerator and denominator. If we divide two negative numbers, they become a positive. So this would simplify down just to be 4/9. And I'll leave that as a fraction. So the directions that ask us to do point slope form first. So that's what I would start with. I'm going to substitute in my point and my slope. And that's part of my answer. That's one of the answers they wanted. So y minus 1 was 4/9 times x minus 5. Again, rewriting this into slope-intercept in standard, we're going to have to distribute. So this will become 5 over 1. we'll get 4/9 x minus 20/9. And I'm going to add 1 to both sides. Now again, to add fractions, we need a common denominator. So I'm going to make this 9/9 instead of 1/1, because 9 divided by 9 is still 1. So we'll have negative 20/9 plus 9/9. Negative 20 plus 9 will get me negative 11. So we have y equals 4/9 x minus 11/9. Last but not least, we want to rewrite this in standard form. So the very last step is to, let me pick a different color down here. I'm going to subtract 4/9 x. And that will get me negative 4/9 x plus y equals negative 20/9. Another form of the answer would be to multiply all of these by 9, which would get me negative 4x plus 9y equals negative 20. We also could multiply each of these by a negative 1, changing the sign to be 4x minus 9y equals 20. All three of those are the same equation, depending which one you prefer. Oh, excuse me, I have a mistake here. I had 11, and then somewhere up here I brought the 20, so let me fix that. These should all be 11s. Okay. 11, negative 11/9, negative 11, and positive 11. You do want to make sure you're familiar with all of the different forms that we talked about and the equations. These need to be memorized. Okay, they're super important. We'll use them throughout the year, especially in chapter 2. A couple more examples that we did not get to in class were finding our slope. Okay, so for this one, again, to find my slope, I'm going to solve this for y. So I would subtract 3x. Again, I always put it instead of 1 minus 3x, negative 3x plus 1. And then I would undo multiplication with division. The question didn't ask me for the equation. They just asked me what is the slope. So I just need to identify that the slope, negative 3x. Now the last one in this section has just variables, a, b, and c. You're going to do the same thing, just like when we solved literal equations. So I would subtract ax then I would divide by b. This actually is going to yield us a little pattern. So the slope of this is negative a over b. So if you look back at all the other problems, we could use this as a kind of rule for finding the slope when something is in standard form. We'll take negative a over b. Negative 3 over 2 was my slope. Now for this one, you would have to clear out your fractions. Negative a, negative 4 over b, 3. Okay, so if you want to memorize that pattern, you can use it, and then you wouldn't have to show work for any of these problems. Okay. Now, other problems we didn't finish at the end were our parallel and perpendicular. So I'm going to show these a little bit different too. So this one, we want to write the equation of a line that goes through this point, which will be my x1, y1. We want it to be perpendicular to this line. So we know that perpendicular lines have opposite slopes that are opposite reciprocals. So the slope of our new line, our perpendicular slope, will be the opposite reciprocal of the given slope. So we flip the fraction and we change the sign. So this would become negative 3 over 1 or just negative 3. Now, if you didn't like what I showed in class where we graphed the line first, you can use the slope and the point and plug it into point slope form. So we have y minus 5 equals negative 3 times x minus a negative 1. We should get y equals negative 3x plus 2. So if you prefer to do it algebraically and then graph it, that's perfectly fine too. Remember, we also could have plotted the point at negative 1, 5, and then we could have counted down 3 over 1, down 3 over 1, down 3 over 1. We would have found our y-intercept was 2, and then we could have written our equation. Okay. The last couple, this one is a parallel. So remember, parallel lines have the same slope, and they have different y-intercepts. So if we want to write a line that is parallel to this line, the parallel slope of our new line will have to be the exact same, just 2/3. And then you have your two options. You can plot your point and graph the line first, and then write your equation, or you could use point slope form. So if we want to show the graphing, we would plot 1, 2, 3, up 1. The slope is up 2 over 3. I'll also go down 2 and backwards 3. And then at that point, I can see that my y-intercept is negative 1. And I can plug into slope-intercept. Y equals 2/3 x minus 1. The last one, we are to write the equation of the line that is vertical and goes through the point 5, negative 3. So 5, negative 3, and it's vertical. Remember, any line that is going up and down, the slope is undefined at that point, and the way that we write the equation is x equals that number, 5. Again, x is 5 here, 5, 1, 5, 2, 5, 3, 5, 4. X is always 5. The horizontal one at negative 2, 2. Horizontal, meaning the slope is 0, or a flat line. Those are the equations where we write y equals that y value. Again, that's because this would be like 0, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2. Y, the y value is always 2. We saw those on our summer packet. The closure question just asks us to determine whether the lines are parallel, perpendicular, or neither. So again, observing your slopes. Parallel lines will have the same slope, but they will have different y-intercepts. Perpendicular lines have slopes that are opposite reciprocals. Okay, so for example A, we can just observe the slopes, 3 and negative 1/3. So right now those slopes are opposite reciprocals. Check out your y-intercepts. We do have different y-intercepts, so these have to be perpendicular. Example B, we observe our slopes. We see there 4/5 and 4/5. We check the y-intercepts. The y-intercepts are different. Same slope, different y-intercept. These are parallel lines. Okay, now the last one we have in standard form. So we would want to make sure that we converted this into slope-intercept form first. And then divide everything by negative 4. Which will get me y equals, the two negatives would cancel to be 2/4, which is also 1/2 x. 8 divided by negative 4 is a negative 2. And then for the other equation, I would add 4x. And then I would divide by negative 2. And I'll get y equals, 4 divided by negative 2 would be negative 2x. 8 divided by negative 2 would be negative 4. So now we can compare our slopes. The slopes we can see, oops, maybe choose a different color there. 1/2 and negative 2, technically that's negative 2 over 1. So these are opposite reciprocals. Remember, the y-intercept could be the same or it could be different when you have perpendicular lines. So really the opposite reciprocal is what stands out, which will tell me that these are perpendicular lines. Okay, the only homework that you have then is you're doing the worksheet that I passed out in class, which was two-sided. You are going to only be assigned the odds. If you would like to do the evens as well, you can. The answers for all of them will be posted, but I would like you to check your answers on Google Classroom before you come to class.